TOA. I'm going to do it again. All right. So we're going to start by writing the most important part of trig that you need to remember, and that is SOHCAHTOA, S-O-H. Stack them up like that. That's SOHCAHTOA, T-O-A. So what this is it gives you the three basic trig functions, which are sine, and that's actually spelled out S-I-N-E. Cosine, which is C-O-S-I-N-E, and tangent, which is T-A-N-G-E-N-T. Before I started my video and started recording, somebody had asked like if you would ever use this in real life. And I gave an example about like my dad trying to build a ramp and needing to know an angle to cut his board at so he wouldn't mess up the board. And a friend of mine who also teaches math, her dad needed to like attach some kind of something back to a tractor. And she had to figure out the angle that it needed to be attached at. But also my grandpa was an electrician and he never finished high school. Like it was back in the day when you didn't have to even go to high school. And he had a little chart that he kept in his pocket all the time when he was working that had different sine, cosine, and tangent values. Because when you are, now I don't know all about electrical work. Mr. Powell would be a whole lot better person to talk to. But when you're running line to stuff, you have to sometimes like make some pipes and bend them at an angle. And some of those pipes are really, really expensive. I think it's called conduit. My papa said conduit, but I'm pretty sure that's not the right way to say it. And this is another just real world application for that. So sine, cosine, and tangent. These are abbreviations. We don't say sin, cos, and tan, just like if you were telling somebody the road that you lived on. And if you lived on, I don't know, Liberty Avenue, you would write it out Liberty A-V-E, but you wouldn't say Liberty Ave, you would say Avenue. Or if you lived on Old Town Road, you wouldn't say Old Town Erd, you would say road, even though you would write RD, right? So you're not going to say sin, cos, and tan because that's like saying Erd, and you don't live on a Erd, you live on a road. So this is sine and cosine and tangent. The other parts, the O and the H and the A, they come from parts of a triangle. So the H is what we're going to start with. The H stands for hypotenuse. And the hypotenuse, if you will remember from like middle school or from like last week when we were talking about altitudes in right triangles, the hypotenuse is across from the 90. So I'm going to put mine in a different color. If you've got a different color, that's a great idea. If you want to just highlight it, it's another good idea. The hypotenuse is the only one of these three labels, the O and the H and the A, that's going to be anchored in place every single triangle, no matter what angle you're using. Okay, just making sure. So sine, cosine, tangent, hypotenuse, opposite. And you might remember opposite from when we talked about opposite sides and opposite angles back at the beginning of the year. The opposite sides and opposite angles were as far away from each other on the triangle as you could get. The opposite side would never ever touch that corner of the angle that we're using. And then the last one is adjacent. A stands for adjacent, A-D-J-A-C-E-N-T, adjacent. And adjacent means next to or touching. We talked about this in that same conversation with opposite sides. And I said that my room was adjacent to Coach Burris's room. They are side by side. Unless you're at the very front by the door, and then we're adjacent to a mechanical closet. Over by the flag, we are adjacent to the hallway. It just means whatever it's next to and like butted up against. So the opposite and the adjacent, they're not like the hypotenuse. They're not anchored in place. They're going to move a little bit depending on which angle of the triangle you are using. So the first thing we're going to do is actually to just go and label the hypotenuse, the opposite, and the adjacent on a couple of these triangles just to make sure we can identify them well. So I'm going to start with number 1. And this says tangent of Z. That's how you read that. It's not tan Z, it's tangent of Z. And this back here, this Z, lets us know what angle we're using. So we're going to mark angle Z on our triangle. And this is one of those things that you would probably do early on, but by the time you're done with trig in geometry class, you might not need to. But for now, it's a good thing to do because it lets us see exactly which angle we're using. I recommend labeling the hypotenuse first. The hypotenuse is always across from the 90, and it's always going to be the longest side in a right triangle. So of your three options, which one is your hypotenuse? 21, the 28, or the 35? 35, good. Then I usually move on to the adjacent because the adjacent side is going to be touching the angle we use, but it can't be the same as the hypotenuse. So which side is the adjacent? So see how the 28 side, it runs into this corner that we're using over here? The only two sides that are going to make up that corner are the hypotenuse and the adjacent. Also, it's worth noting, you're never going to do the sine, cosine, and tangent ratios for the right angle. So that's not going to get used. That means 21 is our opposite. And as you can see, it's all the way across the triangle from the angle that we are using, angle Z. Let's do the same thing on number 2. Angle C is the one that we're using, which is right there. And we need to know the hypotenuse, the adjacent, and the opposite. So of your three sides, which one is the hypotenuse? Good, 34. And then which one is the adjacent? Good, 16, good. And so that means 30 must be the opposite. Now it's not 16 because it's on the bottom like this one was. It's 16 because this side runs into this corner that we're using. It's going to be just the hypotenuse. It's already been used. It's not an option anymore. And it's either the 30 or the 16. And the 30 doesn't touch our angle that we're using. Let's jump down a bit to number 6 because that puts our angle in a different position. Now we're using angle A, which is over here, but our triangle is turned. And so I wanted to kind of move things around a bit for this. So 32, 24, and 40 are your three side lengths. Which one is the hypotenuse? Good. Always the longest, always across from the 90. So then which one is your adjacent? Good, good. And so that means 32 is the opposite. And let's do number 8 as well. So sine of C. Here is C. I want to see what you go ahead and label them first. I'm going to give you a minute to think, and then we'll check them. So which one is the hypotenuse? And then the adjacent is, whoop, not 14. There it is. And so the opposite is 14. So what questions do you have? We all good? Okay. Now, I'm going to go ahead and tell you, everything that you will ever do with trig is going to come back to SOHCAHTOA and being able to accurately identify the opposite and the adjacent and the hypotenuse on a right triangle. So if you're struggling to identify the opposite and the adjacent and the hypotenuse, let me know. The sooner the better so that we can do some more practice. It's really just a matter of practice. Once it clicks though, you're going to be good. So if we're all good, we good? Okay, then we're going to move on and find these ratios. So back up to the top. This says, find the value of each trigonometric ratio. So underline that. This ratio is just a fraction. If it says find the ratio, they literally just want you to write down the fraction. And the little trick that we had up here, SOHCAHTOA, that tells us how to set up our fractions. So literally, when we do the tangent of Z for number 1, we're thinking SOHCAHTOA, because T goes with tangent, and that's opposite over adjacent. So our problem is going to say tangent of z equals, and then we just plug in numbers. We've already got the O's and the A's labeled. So which one goes on top? And then on the bottom is 28. And there you go. That looks like a 2. I'm just going to change that to make it look not like a 2. You can simplify this, so we probably should. So tangent of z is 3/4. They both get divided by 7, and there it is. It's worth noting to read your instructions here. Different exercises, like if you did an Edge Elastic versus an IXL versus Mastery Connect versus a worksheet. Some would want a fraction that's simplified, and some would not want a simplified fraction because they just want to see if you're looking at the right numbers on the triangle. So there's number 1, all done. Number 2, cosine of c. So in your head, you're thinking SOHCAHTOA, ca, C-A-H. And then you're going to write down cosine of c equals blank over blank. So which one is our A as we've labeled it? And then the H is 34. That's it. So that's all you do, at least for now. Now, when you come back in on, what day will you guys be here? Friday will be a weekly check, but then Monday we'll be doing some more notes. And then we'll start talking about solving for how many degrees is in this angle. Or if it tells you the angle, solving for a missing side. But that's really not bad either. If this is easy, then the other stuff later will be easy also. It really only gets hard when you try to do too many new things at one time. And so I like to take trig real slow, and we just spend one day setting up fractions and typing stuff in the calculator. And then the next day we solve for some missing parts that are pretty easy. And that's pretty much all there is to it. So these are both even. It's going to be 8/17 is the simplified version. So let's try sine of c, number 3. Now we haven't labeled this one, so I'm going to leave it up to you if you want to label them first or if you want to set up your problem first. But you're doing SOHCAHTOA with angle C, just right there.
So how do you find out like which you'll be using?
Like which angle or which numbers?
C, T, whatever.
It will tell you. It will either tell you, or once we've got more practice with this, maybe it will. Let me flip over on the back to just give a random example. Oh, well, it's telling you right here. See, sine of C. And so we're using sine. And sine is opposite over hypotenuse.
I am still a little lost. It's the first
Okay.
in the top corner.
Okay.
Yeah, up here. SOHCAHTOA. All right, let me finish this fraction right here.
I got you now.
Okay.
I keep looking at the C and the X and the Z.
Oh, okay. So the parts of these, thank you for asking. I do appreciate that, both of y'all. The C and the X, the letters, those are going to be your angle. You're going to use sine and cosine and tangent almost always with an angle. And so this part that we're circling goes with an angle on a triangle somewhere. The sine and the cosine and the tangent, this part will be told to you in the beginning. Later on, you might just get to pick on your own. Like it might say, find the measure of angle Z. And you could say, okay, cool. So I'm going to use tangent, opposite over adjacent. And then I can use that to solve for the angle. Or you could use sine of Z, 24/40. Or you could use cosine, 32/40. So it will either tell you or you will choose based on the sides that you are given. So let me walk you through this one with tangent of X a little bit more slowly. So tangent lets us know that we're using TOA up here. SOHCAHTOA. So that is our fraction that we are setting up. This X tells us which angle on the triangle we are using. So that's why we go down here and we mark angle X. So that gives us all of our instructions about what to do. We're going to make a fraction using the side opposite from X and the side adjacent to X. And that's all it's asking for right now. So tangent of x equals the opposite side over the adjacent side. So which side is opposite from x? You got 40, 32, 24. Good, 32. Okay, it's the one all the way across the triangle. And the adjacent side is the one that touches the x and is not the hypotenuse. So the adjacent is 24. And you can simplify those. I didn't simplify number 3 because we were kind of explaining stuff, but you can do both. 8 times 4 is 32, and 8 times 3 is 24. And then just to go back and simplify number 3, 7 times 4 is 28, 7 times 5 is 35. There we go. All right, so we've already got 6 labeled. I'm going to give you a minute to set up the sine of angle A. Or ask questions if you got them. Or both. So if we're doing the sine of angle A, what number is going to go on the top or in the original fraction? SOHCAHTOA, S-O-H. And then the bottom is, and you could simplify if you wanted to, or if it tells you to. 8 times 4 is 32, and 8 times 5 is 40, so 4/5. Okay, so what questions do you have before we start doing multiple things with each triangle? Paper's going to get busy, just the paper is, so I don't want to overdo it.
Should we do one more?
Yeah, well, we're just going to find the sine and the cosine and the tangent of a given angle. It's not that much. All right, so our first angle is going to be angle A. We are not going to simplify these because we're just not going to have room. But we want to find the sine of A, the cosine of A, and the tangent of A.
So we'd be doing that, but setting it up. We'd be doing the same thing, but setting it up as the S or whatever.
Yeah, so you're just going to set up all 3 fractions.
Yeah, I do.
Yeah. And then we're going to do all the angles from C, and we're going to look at a pattern that's in there that'll save you some work later on. All right, so sine of A. If I'm looking at angle A, the hypotenuse is which one? 30, 16, 34. Hypotenuse. Good. Hypotenuse is 34. So the adjacent is which of the other 2? Good. So this is going to be the opposite. So sine, so up at the top, SOHCAHTOA, O over H. The O number is 16. The H number is 34. We're not going to simplify because I want to leave all of this room over here. Ka, C-A-H, A over H. A is labeled 30. H is 34. So 30 over 34. Not going to simplify because I want to keep that room. And tangent. Tangent is TOA, T-O-A, O over A. The O is 16. The A is 30. So 16 over 30. And once again, not going to simplify because I want the room over there instead. If you have 2 colors, this would be the time to grab a separate color. And what we're fixing to do is we're going to do the sine, cosine, and tangent of the other angle, which is C. So I'm going to just write down sine of C, cosine of C, tangent of C.
Dang, we doing all that?
Just like once or twice.
Come on,
You'll be fine. All right, so we're going to relabel with this new color because we're now using a new angle. Which of the sides is going to have the same angle or the same label still? Is the O or the A or the H going to stay put? The H, there it is. The hypotenuse stays put because it's always across from the 90. It doesn't matter which of those two angles, A or C, you're using. The hypotenuse is always in the same spot across from the 90. So then the adjacent side, if I'm now using angle C, the side adjacent to angle C is what? And then the opposite is 30. So you can see our sides, the O's and the A's, they've switched places. Let's look at what that does to our fractions over here. If I'm finding the sine of C, it's still opposite over hypotenuse, O over H, but now my O is 30. The hypotenuse is still 34.
So it's like you're keeping the same denominator, but changing the.
And then the cosine, cosine is adjacent over hypotenuse still. The fraction, the A and the H, it's always going to be the same. So, ka, toa, never changes. But which side is now the A? It's not 30 anymore, 16. And then pause after you've written 16 over 34. Looking just at those top two lines, what pattern do you see? Where do you have some? Flip what? You could describe it that way.
You flip the numerator, the two top numbers.
So the two top numbers. So the sine of A and the cosine of C match. They're the same exact thing. And the cosine of A matches the sine of C. Those two match. That will always be the case, 100% of the time. Good. Yeah. Yep. So let's go ahead and do tangent. Tangent's opposite over adjacent. The opposite's now 30, the adjacent 16. You can see that's the inverse. You just flip the fraction over. So what we got going on here is something that you can use as a little bit of a shortcut. And in fact, that's one of the most, one of the main things that you're supposed to take away from geometry, other than just the sine, cosine, and tangent concepts, is knowing that the sine of one of these angles is going to be equal to the cosine of the other one, and vice versa. The sine of this one, the cosine of that one. And that's because those two angles are complementary angles. It's not just if you see it in a triangle, it's any complementary angles, even if you don't have a triangle drawn. So we're going to move down to the bottom of the page real quick and make a note about that. Because like I said, that is one of the most important things that you're supposed to take away from the study of geometry, of trigonometry in geometry class. So we're going to write, if two angles are complementary, complementary means they add up to what? Nope. There it is. You're not the only one. When I was in middle school, my teacher said the supplementary angles ate too much supper and had to lie down. That's how we're supposed to remember they were the straight ones that lay down, 180. So. Or that. So if two angles are complementary, the sine the sine of one will equal the cosine of the other. And then we're going to give an example with just some numbers. Right now, our angles have all just been letter names, but you can put some numbers in there. So let's say sine of 30 will equal the cosine. 30 plus what would make 90? Close. That's 100. He's struggling today. It's all right. So the sine of 30 would equal the cosine of 60. And the sine of 60 would equal the cosine of 30. And you could do that with any two numbers that add up to 90. You could do it with 45 and 45. You could do it with 50 and 40. You could actually even do it with 100 and negative 10, stuff like that. As long as those two numbers add up to 90, that statement will be true. The sine of one will equal the cosine of the other and vice versa. So what we do also need to add is how you're supposed to know that they're complementary, because there's about 3 ways that you could know. How to know if angles are complementary. Okay, so I'm not trying to insult your intelligence, but the first 2 or 3 are going to be real obvious. First one is, it will say the word complementary. Sometimes that will be in a problem. It will say, if X and Y are complementary angles, which of the following statements is true? And you'll pick the sine of X is equal to the cosine of Y, or the sine of Y is equal to the cosine of X. Okay, so the word complementary. Second, the two acute angles in a right triangle. That's what we have. Oops, you can't see that. I'm sorry. The two acute angles in a right triangle. That's what we have all over this page. Every single triangle on here is a right triangle because it's going to have to be to do trig with it. And those two acute angles, as we just saw, will have that pattern. It's because of how the opposite and the adjacent labels move around. Okay, the next real obvious one, there's 4 actually, sorry. The numbers given add to 90. So if it says like, which of the following is equal to the sine of 30? And you've got A, B, C, D. You're looking for the cosine of something that makes 30 plus that equal 90. Okay, or if it says, given that the sine of 45 equals X, which of the following is also equal to X? And you're going to pick cosine of the other number. All right, last one. This is the one that's a little bit strange, so I'm going to put a little star on it instead of just a dot. Expressions like X in parentheses and more parentheses 90 minus X. Expressions like X and 90 minus X. So you might see the sine of X is equal to the cosine of 90 minus X. So if you think about what this is, right, this is how we found 60 a minute ago. I said, here's 30. What plus 30 is going to equal 90? And what you do mathematically is you subtract to find that out. So when you put it in an expression like that, though, sometimes people don't realize that's what's going on. And so sometimes this is used to make these questions seem a little bit harder. So if you have X and you have 90 minus X, those are going to be complementary. If you tried to add them up, the X's would cancel. Because here's a minus X and here's a positive X. So you would just be left with 90. That's how we can kind of prove that those are complementary angles. So there's that. All right, so let's do it again. We're going to do number 7. We're going to use angle Z to start with. The hypotenuse is 40. Which one is the adjacent? Nope. Yep. And so the opposite is 24. So sine of Z, cosine of Z, tangent of Z. So katoa, S-O-H. So what is the top number for sine of Z? And the bottom number is CAH, C-A-H. Cosine's top number is, thank you, and the bottom is still 40. And then tangent, TOA, opposite over adjacent. Good. Not 40. 32. Good. Okay, now cover up that triangle. Once you've got that written down, cover up the triangle. And we're going to find all of the other ones. Which one? What's my other angle? My other angle is X. Which one will be equal to the sine of X? So X is your other angle. Good. So cosine of Z. So we're just going to put over here equals sine of X. Those two, the sine of one angle and the cosine of the other angle, are going to be the same amount, same value, same number. So the sine of Z is going to be equal to what other of X? That one. So cosine of X. Okay, so once again, the sine of one, sine of Z, is going to be equal to the cosine of the other, X. So you've got a Z and an X, you've got a sine and a cosine. Same thing down here, you've got X and Z, you've got sine and cosine. Now this one we can't do like that. We have to go ahead and put tangent of X, but then what do we do, Chance? There you go. And we just flip it, okay? So that'll save you the extra step of going back through and relabeling stuff from the other angle, okay?
So I can do it like that instead of doing the whole thing.
Yes. Yep. All right, and so then one last little thing over here. This is not triangle related necessarily. I want you to draw like a circle or an O and put a line through it. This is a theta. Theta. Theta is a Greek letter. So we're going to put, looks like a what? Yes, it does. When you draw it in green, it does. It is a Greek letter. Just like that. It is. It's a name of a letter. Used as a variable for angles. Okay, now pi was real weird when you saw it the first time too. Theta? Theta's a word. It's the name of that shape. You know, like, you know, if you're in fraternities and sororities, you know, you have like alpha, delta, kappa, right? This is a theta. Mu, alpha, theta. Something like that, yeah. So where you're going to see this is in trig, primarily. And it's going to be used as an angle variable. So instead of saying sine of C, it might say something like this. Let me get a different color so it doesn't all run together. If sine of theta equals 48 over 50, which angle is theta? See, so that's not hard. SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse, right? So if the opposite is 48 and the hypotenuse is 50, then this must be the adjacent. So which angle are we using to label the O over here and the A over here? Are we using A or are we using C? A. There you go. You solved it. Yeah, that's right. Nah, it's not too bad. The good news is theta, you probably won't. I just wanted to get you exposed to it today. Like it's not going to be something that's going to come up immediately and a lot. But whenever it does show up, I didn't want it to surprise you. So what we're going to do today, you have 2 IXLs that you're only working up to 50 on.
Oh, I can't set them up right.
Okay, well, we will work on that. So the first one is trigonometric ratios, sine, cosine, and tangent. You're only working up to 50 because when you work up higher than 50, it starts giving you a bunch of radicals to simplify. If you feel like doing that, that's fine, but that's not something I want to teach. Maybe, yeah. I mean, you're not going to have the same problems, but sure. So cosine of k, right? Here's k. Cosine is adjacent, 5 over hypotenuse, 13. So you just click that little fraction, 5 over 13, done, right? The other one is even easier. The other one is find trigonometric functions using a calculator. Notice this doesn't say the ratio, right? You're not making the fraction here. You are literally typing cosine 75 into the calculator, and that's it. No, let me show you. I'm going to tell you. All right, so on your calculator, over beside the 7, there is a button that says Trig, and there it is. Sine, cosine, tangent. And there it is. Now, yeah, you just use whatever function they say. In this particular exercise, they do go ahead and throw in some of the other ones, like the CSC, cosecant, and the SEC, secant. Yep, it's going to be a decimal. And so it says, write your answer as an integer or as a decimal rounded to the nearest hundredth. So round it to 2 decimal places. And there you go. That'll be all the way up. This is a super, super easy one to get a 100 on if you want to. 50. You only have to get it to 50. So for those of you at home, either now or later, you should, like if you have an iPhone, you should be able to use the calculator and turn it sideways. So let me show you mine. Okay, so you got your calculator. If you turn it sideways, there's your sine, there's your cosine, there's your tangent. But you have to type the number first on here. So like you would type 75 and then type sine, and it would give you that answer. Okay. Now also make sure if you're using your phone, the ones in class are already set up this way, but there's 2 different ways that you can calculate these. They're in radians and degrees. So if you're at home, radians, if it says RAD up there, you don't want that. That will give you a different answer. Watch. 75 sine. See, it's a different answer. You want it in degrees. Huh? Better not. You just type it in the calculator. And if you don't have an iPhone, you can probably find just any calculator. There are a lot of real basic calculators that you probably have laying around your house that are going to have sine, cosine, and tangent. Otherwise, you can also type it into your, I think you can type it into your search bar up here. So you can write like sine 75, and there it is. But you want in degrees. Sine 75 degrees. There you go. Okay. So there's some options for those of you working at home as well, either now or later. Taylor, right now. All right. Any questions from anybody? Okay. All right. Yes. I'm going to pause our recording, or actually I'm going to